Welcome to Master Concepts in Chemistry. In this lesson, we will discuss what you need to know to solve mole problems. So first, what is a mole or what is 1 mole? 1 mole is just a pile of particles. So as an illustration, I have a pile of particles in front of us. So this is pile of particles. Now, these particles here could mean atoms, ions, molecules, electrons, and so on. So a mole is a pile of particles. So we can say 1 mole, which is 1 mol, is equal to a pile of particles. Now, this pile of particles also consists of a specific number of these particles. And this number is equal to what we call Avogadro's number, which is 6.02 times 10 to the power 23 particles. Again, particles here could mean atoms, ions, molecules, or electrons. So we can say 1 mole of any chemical, any substance, consists of 6.02 times 10 to the power 23 particles. So if it's 1 mole of oxygen atoms, that means they contain 6.02 times 10 to the power 23 oxygen atoms. If it's 1 mole of hydrogen molecules, it means that this 1 mole of hydrogen molecules will contain 6.02 times 10 to the power 23 hydrogen molecules. Okay, so just keep that in mind. Okay. So this 1 mole contains Avogadro's number. This is a relationship. So this relationship, we can write conversion factors. So we can write conversion factors. And recall, when you have a relationship involving 2 different units, like this, you can always write 2 conversion factors. So let's go ahead and write a conversion factor. So the first conversion factor, which is just a ratio of 1 over the other, we'll say 1 mole over 6.02 times 10 to the power 23 particles. And our second conversion factor, which is the second ratio, called B, is just a flip of the first. So we'll have 6.02 times 10 to the power 23 particles over 1 mole. Okay. So what does this mean? This means that anytime we want to convert from moles to particles, we have to use one of these ratios. Okay, one of these ratios. So again, remember that 1 mole of any chemical contains Avogadro's number of particles. Okay, and a mole just means a pile of particles. Okay. Now, imagine that you are asked to go and weigh 1 mole of oxygen. What would you do? Now, to go and weigh 1 mole of oxygen, what you need to do is you just have to identify the atomic mass of oxygen. Now, oxygen is over here. It has an atomic mass of 16.00. Now, remember, atomic masses on the periodic table are relative units, so they don't really have grams or kilograms attached to them. So basically, if you want to weigh 1 mole of any element on the periodic table, like oxygen, what you need to do is you just have to go and weigh the atomic mass in grams. So we just have to attach grams to all of the atomic masses on the periodic table to weigh 1 mole of any of these elements. Okay, so keep that in mind. So that means that there's always a relationship between mass, mole, and particles. Okay. So let's go ahead and look at this relationship. So we can write this relationship as, mass in grams over here, mass in grams to mole. I'll just write 1 mole here, and then 2 particles. And remember, the particles here could mean atoms, molecules, ions, electrons, and so on. Okay. So from our definition, we said 1 mole of any substance contains Avogadro's number of particles. So meaning we can have one of the conversion factors that we wrote earlier written here. So we would say if we want to go from moles to particles, we have to multiply by the Avogadro's number per mole. So we'll have 6.02 times 10 to the power 23 particles here per mole. 1 mole. Okay, so this is the conversion factor that we need to go from moles to particles. So this is the conversion factor that we need, okay, to go from moles to particles. And we've already seen that. Now, how then do we go from mass in grams to moles? So remember, the periodic table contains the elements. And these elements, of course, do have atomic masses. And we said 1 mole of any element on the periodic table is equivalent to the atomic mass of that element in grams. So that means that to go from mass in grams to moles, we have to use what we call the molar mass of that particular substance. So if it's an element, we use the molar mass of that element. So the molar mass is just the mass of 1 mole of that substance. So if it is an element, it is just the mass of that element, its atomic mass in grams. That's 1 mole. So we'll just say molar mass here in grams per mole, with the understanding that molar mass value will change depending on what substance you are dealing with. Okay, but Avogadro's number is constant, so this value here is constant, so it doesn't change. Only the ratio changes depending on which direction you are going. Okay, so if we want to go from mass in grams to moles, we have to flip our molar mass. So that means that our molar mass will now be 1 mole on top over grams. So that the grams will cancel out and then we'll just have moles. Okay. So that is if we are moving in the direction from left to right. So if you have, let's say, 20 grams of oxygen and you want moles of oxygen, you have to get a molar mass of oxygen, you flip it, and then you multiply by your mass, okay, of your oxygen, and the masses of grams will cancel out, then you have your moles. And if you want to go from moles to atoms of oxygen, you multiply by Avogadro's number. Okay, we see examples of this in our next lesson. So what happens if we are moving in reverse? So let's say we are moving from the right to the left. Remember, the first was from left to right. So now I want to go from right to left. So to go from our particles, which could be atoms, molecules, or ions, to moles, we have to use our Avogadro's number again, but we have to flip it. So we have to flip it. So the ratio now becomes our 1 mole will be on top, and our Avogadro's number will be at the bottom here. Okay. So that is that. So particles will cross out. Okay, and you just have moles. And to go from moles to mass in grams, we have to use our molar mass in its original form, which is usually grams per mole, so that the moles will cancel out and we'll just have our mass in grams. Okay, so here I'm going to put the second arrow here, so moving in that direction. So you see, so this is a relationship that you need to keep in your mind. So to go from mass of a sample to moles, you have to use your molar mass, but you have to set up the right ratio. So which of course would be your 1 mole of your substance divided by the mass of it in grams. So if it's an element, that is the atomic mass in grams. If it's a molecule, you find the molar mass of it using the periodic table. And once you get your moles, to go from moles to particles, you just multiply it by the Avogadro's number, okay, which of course is 6.02 times 10 to the power 23 particles per mole. Okay. So the next question is, what is the significance of the mole concept? Now, the mole concept is just to help chemists count and weigh these invisible particles. So remember, we can't see atoms with our eyes. So we have to use a unit that will allow us to to be able to weigh these invisible particles and count them. And that's where the mole concept comes in. So the mole concept connects the microscopic to the macroscopic. Okay, connects the microscopic to the macroscopic, because human beings, of course, function well at the macroscopic level. We want to see, touch, feel things, but nature, manipulate these atoms at the microscopic level. So the mole concept comes in to bridge the gap between microscopic and macro. Okay, so it allows chemists to count or weigh these invisible particles. Okay, so in our next lesson, we'll look at how to calculate some mole problems.